All right, everyone, we're going to get started here in just a minute.
Everyone ready? No problem. Okay.
So thanks, everyone, for coming out. Appreciate some familiar faces, some new faces. Thank you for letting us have the space. Much appreciated. So I am, for those of you who have not met me before, I'm Trent Nielsen. My title is Enterprise Architect. I work for PXG, which is a golf club company. I'm also an independent consultant. I do mainly cloud consulting, but also infrastructure consulting. And then I am one of the co-founders and leaders of the Amazon user group here.
Hi, my name is Justin Wheeler. I'm a senior software developer at Bravo LT, 13-time AWS certified. I'm an AWS community builder since October 21 and AWS user group leader since January 24. If you want to connect with me on LinkedIn, there's my handle. My handle on everything, GitHub, so you can check me out. We're going to talk about our sponsors first. Thanks to GRCC for lending us the space, and Bravo LT is sponsoring this event. They're also my employer. So Bill Osborne can talk a little bit about Bravo LT for a little bit.
Hey everybody, I probably don't speak too much. Big shout out to GRCC for letting us borrow this space. We decided to borrow this space. Beautiful campus, great show up. Having us. My name is Bill, Director of Recruiting at Bravo. But according to Bravo, I love this slide. You know, I think that we're a software development shop here. There's about 40 of us. We're an international organization now with home here in Grand Rapids, and also offices in Monterrey, Mexico, Poland. Back this one more time. I'm sorry. I screwed this up.
Oh, you want to go back?
Yeah.
Oh, okay.
So I think the big thing that I get really proud of every day at work is that circle right there. We talk about it quite a bit. We go out and we hire the best employees in our communities, and the clients become easy. They continue to grow. They continue to get stronger relationships. And because of that, we're making more money. We get more back to the community like this. Also, Raspberry Pi coding camp. That we're coming up with that has middle schoolers into coding. But it's more we are interact with the community. It's easier for employees, clients, and the community, right? So you sort of see how that circle goes. So something I'm really proud of that we do every day. Just going to hit one more time. I'll let you guys read, but really focus on 6 areas of expertise: cloud services, ran by Justin Wheeler here. He'll touch on a little bit of what we do from a optimization standpoint. We also supply dedicated Scrum teams, staff augmentation, agile pods, custom software. And where we started was learning and development, so all those knowing trainings as fast as possibly can be here. Probably created the base layer of those. So you guys are ever looking for jobs or employment? You're ever looking to augment your teams? Love to connect with you guys. I didn't bring fancy cards. I've been really terrible at that post-pandemic. I probably had the same box of cards. I got it like in 2020, and it just sort of sat there for since fucking dust. I don't know. It's like a time capsule to a time before. I'll bust my one of these days. But happy to be here. Get back to these guys.
All right, thanks a lot. You can get this slide.
So I don't know if anyone's ever seen this meme before, but there's some truth to it. You turn it on, it's like leaving the lights on, except for times 1,000. You incur an hourly on-demand charge, and it'll put you in the poorhouse. I've recently stood up a couple Amazon accounts for the user group, and it's on my own personal credit card because this is a community thing that I do. And so there's some nervousness that comes with that, right? And as a newcomer, you don't want to be put in the poorhouse by leaving a server on longer than you should or deploying the wrong one. So it's always important to be cost conscious when you're running any workload in Amazon. So whether it's a server, whether it's a function, whether it's a database, and it all starts with a good tagging strategy. So anything that you deploy in Amazon is called a resource. Those tags are attached to those resources, and those resources can be used to categorize your costs. And without a good tagging strategy and good sound tagging tooling, you are not going to have a good handle on the accounting of your business. And so it all starts with tags. Tagging doesn't have to be overly complicated. You can think very concise. If you think about buckets that you organize your applications into, you want to create tags based on those buckets. In my organization, the big ones are a region, the name of the stack, the type of service, the component that is running, the environment, and the variant, and then the business unit. So instead of, we have a couple different sub-teams, but it's mainly the team business unit that's assigned as the tag. So that way you have accountability for how much does it cost to run in one region, what kind of components are costing us the most, and so on. So good coverage is required for accurate, effective cost reporting and monitoring. When you start rolling out your tags onto your resources, there's a small section of billing and cost management that'll show you your tag coverage. So how many resources do you have versus how many are tagged with that resource? And it's really important that you have good coverage, because if you have good coverage, then you can get the details of those tags. So once you start rolling out your tagging, you'll start seeing these numbers creeping up. You know, when we started on our cost journey for this year's audit within my org, saw 107% increase, and that was really digging in and making sure that every single piece of code and every single resource that's deployed is repeatable through functions. And then once you have all of your tags called out as cost reporting tags, you then have the ability to go into what's called, this tool is called Cost Explorer, but allows you to drill down by tag, and you can combine numbers of tags any which way that you can think of.
I can take this one. So you can set up anomaly detection in the billing console, and you really should. It can detect you to anomalous bills. So maybe you're steady going and then it just spikes one day. So you'll be alerted by that.
Yeah, anomaly detection is automatic. It uses machine learning under the hood, and you can set it up just to, if something looks out of the normal, out of the ordinary, I should say, you can get notified. So in addition to anomaly reporting, you have Cost Explorer, which is an on-demand graph of what we showed you with all the tags previously. You can export your data, so it can be ingested by a BI analytics tool. You can go to a S3 bucket for ingestion if you have some kind of homegrown solution that's pulling that data in. Anomaly monitors we touched on. And then you can have what's called a threshold alert. So if you only want to, if you have a maximum tolerance for what you want to spend, you can set a threshold alert to alert you if you go over that threshold.
All right, compute savings. So compute is usually the highest line item on most bills. This is your processing power, your memory, and it's going to be the highest cost, usually.
Mine's RDS. Ours data is number one for us.
Okay. So the first thing is right sizing. So you want to make sure that you're not over provisioning or under provisioning. Just provision exactly what you need for your application. Because if you provision too much, you're paying too much. If you provision too low, then your customers are having a bad experience. And there's some different ways to do that. The first one is an AWS tool called Compute Optimizer. This is an opt-in service that you have to opt in to use. And then it'll start gathering, using machine learning and gathering data on your account to make recommendations based on the instance types that you have selected. And it has recommendations for EC2, ECS, and Lambda as 3 different compute services that you can work with.
So there's many different instance types. There's ones that have more memory, there's ones that have more compute, and then there's different generations. It's really important that, as the fishbowl analogy, and you get a small fish and sometimes it grows into the bowl, and sometimes you have a fish that's too big for the bowl that you have. Make sure that you have the right size bowl, and quite frequently you have to go back and make sure that that fish isn't too big or too small for it. We'll talk about what the different instance types are, but make sure you're using the right one for your workload, because it can mean the difference between a 2XL or an XL, and which is frequently double the cost between the next bump up, right?
Yeah. Just to elaborate, in the general purpose, you may have a even CPU and memory, like 4 and 4, but compute optimized would be like 2 and 8. So you have 2 memory and 8 CPU. Memory would be reverse, so 2 CPU and 8 memory. And then accelerated computer is like your GPUs, your field programmable gate arrays. If you need to do like hardware accelerating, that would be the
Crypto mining.
Very expensive, this area. Thousands of dollars. Okay, so I'm going to break down an EC2 instance type. So this is composed of different attributes, like you see. The family, so this is general purpose because it's a M or main. Instance generation, so this changes rapidly at their pace. So AWS will innovate, they'll release a new generation, and you can upgrade to the new generation for usually better performance at a lower cost point. And then the instance capabilities. Usually. Instance capabilities, so this will vary. It may be absent completely, but it's like AMD or instance storage, stuff like that. And then the instance size.
I was pretty shocked to learn recently. It used to be historically that AMD families were a little bit cheaper than Intel. It's not the case anymore. Those newer generation AMDs have a lot more parallel processing power, but the Intels usually can achieve a higher frequency. So again, it's one of those things where your workload may or may not work well with one versus the other. And if they're close in pricing, try to evaluate them as best as you can on each instance family. Because I've found that AMD has been pretty powerful these days. If you can't run Graviton, which we'll talk about.
And then when looking at right sizing your instance, first consider the generation. That is usually a very easy change going from M5 to M6, M4 to M5. Very low risk and huge impact. And then if that doesn't work, look at the family. So maybe you're using the wrong instance type. And then if that doesn't work, then you can look at changing the size. But that'll impact the cost the most. And finally, if your instance is right size and you still want to reduce costs, you can look at purchasing options. And we're going to talk about those later on in a lot more detail. Okay, one last consideration for unlimited mode instances or the T-type instances. These are considered burstable.
They're really, really inexpensive for you to run on demand.
Yeah.
Sorry, I'm stealing this thunder.
If you use them the right way.
Yes.
So in this graph, it's comparing a T3 large to an M5 large. And they're both general purpose instance types, but the T3 is cheaper than the M5 in some situations. So it will accrue CPU credits when it's not bursting above the CPU that's assigned to it. And it can use those credits to go above the CPU to work for bursty workloads like this. So you're not paying extra for high CPU when you only need a little bit of time. But unlimited mode means you can burst all the time. So if you have credits or not, you burst and you pay for the time that you're bursting. So if you're always bursting, it's going to be 1.5 times more expensive than an M5 large.
We use these for Bastion hosts for utility blocks for my team. We have a DBA that uses them intermittently to do dumps in and out, but they're burstable and they don't need to be incurring. And we've moved some of those workloads to be turned off during off hours, which we'll talk about as well. But for anything that's non-production, that doesn't get a lot of use day in, day out, not churning a lot of data, Bastion hosts, these are good. Burstables are a good thing to look at. But the one thing that I would say is that when that instance runs out of credits, it is cooked. It'll say, the literature will say that it'll run, but it runs at such a slow crawl that it makes it almost unusable. And it won't run, in my experience, it won't run the apps that you need. So make sure that these are only assigned to non-production. I mean, you can do burstables on production,
yeah,
but just be careful with how you assign these, because if it's something critical, it may burn you.
Yeah. And if you are using burstable instances, keep an eye on your CloudWatch metric for your credit balance, because if it's constantly 0 credits, then you shouldn't be using the burstable instance.
Yep. Got to bump it up. Or bump it up to a larger burstable.
Yeah, exactly.
Yep.
Okay. I want to share this EC2 shop website that I found. It's a way to scrape AWS prices programmatically, so you can make your right sizing efforts a little bit easier. And this is also a little bit friendlier with digesting prices, because you can see them monthly. And there's some other columns that I dropped off here so it can fit on the slide properly. But you can see like the reserved instance prices in like real English. And you can also use filters on the command line to get exactly what you want. So it's pretty nifty.
So EBS right sizing, you have your compute, obviously, which is your processor cycles and how many CPU and memory you're going to utilize, but then you also have the disk that's associated with it. And EBS can be a little tricky because there's so many different, there's kind of a matrix of throughput versus IOPS that it can support based upon the size of the disk and what storage type the disk is. So there's no one best solution for EBS volume, sadly. It's really dependent on workload. I would say that the baseline would be GP2, but even that's being phased out in favor of GP3.
Yeah, GP3 probably.
So it's tricky. You want to evaluate your storage requirements. You need to, for each of your apps, you really want to hone in on it per app basis. It's hard to do something kind of blanket across your apps because they're so tailor fit to each specific app. So you want to make sure that you're looking at the utilization and how much of the disk are you using. When you deploy a 100 gigabyte disk, you're paying for 100 gigabyte of block space of disk, whether you're using the entire thing or not. So if you're deploying D drives to your Windows workloads and your app team isn't using them, then you shouldn't be deploying them at all. And those add up, right? That's one example. So, and then sometimes EBS isn't the best choice for storing your data. For something like S3, if it's something that doesn't need to be stored on every single instance of every single one of your web servers, put it in S3, access it in a different manner. I haven't used the Windows EFS version.
Or FSX for
FSX. I've never used FSX, but we've used EFS very heavily for a lot of our Linux workloads, and it's considerably less expensive than using EBS.
Yeah. And the last thing on this, if you're going to use IO1 or IO2 volumes, just like triple, quadruple check because they are very expensive.
Not only that, but you can over-provision your IOPS for an IO1 that, for RDS, for example, that exceeds the amount of IOPS that the drive can handle. And they'll bill you for it. I just found that out. Not that it wouldn't be put past them to do that, but...
Okay.
You want to take this one?
Yeah. When considering downsizing non-prod, we don't want to pay 24/7 for resources when our users are only going to use them 8x5. So typically dev is used by developers only for developing new features, and a lot of devs don't like to work on the weekends. But you can do these things to kind of try and reduce those costs. So consider burstable types like we talked about. They're really great for dev environments that may see a lot of traffic during testing a feature, but not a lot of traffic when they're working on their local computers. Consider spot instances. We're going to talk about spot more in the future in the purchasing options section. But that's a great option for dev instances because if the instance goes down, the dev can just try again. Like it's not an impact to a real user; it's an impact to an employee. So you have a little bit more freedom there. And then scale auto-scaling groups to 0 in off hours if you can.
So we run Selenium, which is a testing framework, and it runs on ECS. And it was running 24/7, and we had tests running at 5 a.m. and they went all the way until about 5 p.m. And we scaled those to 0, and they were very large instances because they're running hundreds of concurrent users with all these different browser connections against a web app. And you only need to pay for it, 12 hours a day. You pay for it half the time. And then you turn it off on weekends, which brings it down just a little bit. So we do an 8x5 usually for most of our non-prods, if we can turn it off. But the one thing to consider, if you're turning off non-prod, you have to think about your workloads. If you're running Windows apps that are connected to your Active Directory domain, if you never turn them on to update them, they can get tombstoned. Anyone know what a tombstone is? It's when an Active Directory computer just can't check in with the domain, so you can't log into it, you can't authenticate, and then your security team can't apply GPOs and patches. So you have to consider these things if you're running Windows. If you're running Linux and you have hardening requirements, if you don't have a robust imaging strategy to replace your servers every single time that you deploy, and you're using what we call long-lived instances, a server like you would do on VMware, that isn't disposable, you got to be careful and thoughtful about that. We ran into this recently with a couple of we call them staging apps for the Windows, some of the vertical market Windows apps, and our asset management tool and staging doesn't work. We can't test the upgrade because we need to redeploy the server, right?
Right. And this last one, consider other teams. I have an example when I was working at Verizon, and my onshore manager was like, these costs are too high, shut it off after hours. And then he got woke up by our offshore team in India because they couldn't access anything because it was offline.
Yeah. So consider your offshore teams. But really, if you don't want to rack up your bill, don't run Windows. If you can avoid it, don't do it. It's 3 times the cost for any workload. If we run Tableau as our analytics and reporting tool, if Tableau runs on Linux and Windows, you're going to spend 3 times as much to run your workload on a different operating system. There are some things that come with that, though. You have to have the tooling and maturity of your team to be able to deploy these services on different platforms, and you have to have the operating system expertise. But 3 times as much. And a fun fact, I just recently looked at Azure pricing because I assumed that Azure would be less expensive, but they're not. Windows workloads are about the same. Now, where it lures people in is EA agreements where they get a little bit off the top, but yeah. I digress. It's not less expensive to run your workloads ad hoc in Azure. So Windows, if you can avoid it, don't do it.
Okay, now to talk about dedicated hosts and instances. These are very specific deployment options that you have. So dedicated instances are your applications will not be deployed in on shared hardware or with other tenants. It'll only be deployed on instances that you control. They're going to pay a premium. I think it's $2 an hour on top of any other prices. So it does add up fast. Dedicated hosts are you have an entire rack at your disposal. You can deploy you can configure how you want the instances deployed in there. Maybe you want one huge one. Maybe you want 4 small ones. You get to decide how to rack it up. It'll always start on the same host, and you actually get access to the underlying host capabilities as well, because there's no hypervisor there, I believe. So if you need that for your application to talk to the hardware, then that's an option for you. That's also very expensive, and if there's any hardware issues, that's going to impact you as well. Because with EC2, if you restart an instance, it'll jump to another instance that's available. That's not an option with dedicated hosts unless you buy more than one.
Why would an organization do that?
Okay. Mac instances is one.
OS. What is it? iOS development, right?
Yeah. So if you're doing iOS development, you can run the Mac instances on AWS. However, due to their licensing agreement with AWS, they require dedicated hosts. Licensing requirements. So maybe you have some software, Oracle or other, where you have to use dedicated hosts for instances. You have to do that. Hardware isolation. Maybe you have some compliance or legal reason where you can't have shared tenancy. Hardware isolation will work for you. And you can still use cloud with dedicated hosts. Or I think dedicated instances will also get past the hardware isolation, but it depends on your specific compliance or legal bind you're in, I guess.
The other thing that we have done within our org on the operations side is moved most of our apps to ARM-based workloads. We run ECS containers already. We have a level of maturity where we're running most of our workloads on Linux, but x86 architecture and ARM architecture, 20 to 30% cheaper. If you're starting on your cloud journey and you're starting to build your pipelines and you're just starting to learn how to containerize your apps, you may just want to start with ARM from the get-go. Depending on your CI platform and how you're writing your apps and who manages the parts of the CI platform will really depend on how easy this is. When I say we, I have a team of engineers and a counterpart. My counterpart did most of the work for, I think it's 15 different workloads and was able to convert all of them to be built on ARM. Now, where this helps us as a team that coexists with Mac and Windows users, we can now have the image available for us to develop also locally without having to. Before, some of them had ARM, some of them didn't. But they're 20 to 30% cheaper. And I have found for the common things, web servers, common Python runtimes, these types of things, that almost everything nowadays that is not edge case is pretty well supported in ARM. So it's not a huge lift. It's more of a time lift than it is anything else. You're going to spend the time on the labor to get there, but then you'll have the framework in place to realize the gains on that.
Yeah. Okay. And then this one, stop running EC2 if you can. So AWS has, I think, over 300 services now. They have very specific services for very specific problems, and they might probably have a service for your problem. You could, EC2, if you don't know, stands for Elastic Compute Cloud. It's basically a virtual machine on AWS, and you can get a cheaper virtual machine somewhere else. If that's all you need in some cases. So there are other alternatives that you can use, and you can lower your cost drastically by considering them. ECS is built for running containers. So Elastic Container Service. Lambda is built for running serverless workloads. So you just provide the code and then it scales automatically based on functions or triggers.
This is tricky because not everything can run on ECS. Windows is .NET applications specifically a little bit more challenging to package and build and run on ECS, but it's not impossible. And I read the other day you can run Windows 10 in a Docker container now if you really, really wanted to. I don't know why you would want to, but maybe for fun. But yeah, EC2 is definitely, there's better alternatives out there, especially if it's Linux. If it's Linux, it can run on Docker and ECS. I'll just add that I have very limited experience with Kubernetes. We tend to keep things simple for my organization, so we won't be talking about any Kubernetes savings today. Just want to tell that right now. Tell everybody that right now.
You run .NET on ECS.
I haven't done it on Lambda, and we have microservices that do run on ECS, but packaging an existing EC2 app with MS Deploy, for somebody like me, it's not a hard .NET Microsoft developer at all. It's a lot more challenging. My expertise is more in Linux, even though I grew up on Windows. What is worth? Yeah. Oh yeah. By and large, I don't think we would ever look at Kubernetes with our org, but there's use cases for it, but I don't want to maintain it.
And these three options aren't all of them. There are more options than this. App Runner, EKS, a bunch of other ones.
Yeah, we didn't mention App Runner on one of the other slides, did we?
Yep.
I don't think we did.
I don't think so.
Lightsail.
Lightsail. Yeah. Okay. Consider Lambda in these two specific situations. Just for example, scheduled cron jobs, or otherwise referred to as cron jobs, are very good substitutions for Lambda because you can hook them up with Event Bridge to trigger them on a schedule using cron expressions, and then they'll just run until they're done, and then it stops. Although keep the Lambda timeout in mind, it's 15 minutes right now.
If you have some app that's running a batch service every 15 minutes or once an hour that's processing and sending it from one place to another, put it in a container and schedule it on cron, or create a function Lambda and schedule it on cron. It kind of goes back to the don't pay for what you don't need, right?
Also, bursty workloads work really great with Lambda because it scales based on the triggers or the requests. So if you hook your Lambda function up to a HTTP trigger or like an API, it'll scale based on the number of requests you have. So you have suddenly 1 million users, and you have 1 million concurrent invocations without having to do anything, assuming your quotas let you.
Yeah, quotas are important. An example of this would be if you're running an e-commerce site and you send out a blast of the new product and you have a bunch of people that are trying to register. Well, you can offload that registration process to Lambda so it scales up and scales down as you need it to without having to run another service consistently with that.
Okay, if you are using Lambda, you can look at power tuning, which is it's an option to help you scale your costs and right-size your Lambda functions. So Lambda functions, they give you a memory configuration, and the memory you allocate controls the CPU that's allocated to that function. So this is using step functions, which is another service. It's an orchestration service to run your function with several different memory configurations, and then it charts it for you so you can see the different memory configurations, which are here at the bottom, and then the execution time in milliseconds and the price you pay for that. And you can see at some point you allocate more memory, it's not getting any faster, right? This is not that much faster from this jump for the cost though. You see this cost jump is the same?
Yeah, there's a diminishing return.
Yeah, exactly. That's what it's called. And if you want to check this out, here's a QR code. I'll leave it up there for a minute or two.
This testing for you, or is it actually is it estimated against, or is it?
So you can go on GitHub and download it, and then run it on your computer, and then I'll give it to you. But you have to provision the step functions in your account to run it against your Lambda function, and you give it the right permissions and IAM roles and stuff like that.
Does the repo have a CloudFormation template with it?
I don't remember.
It's an official Amazon one though?
I think it is official Amazon, and it's also on the Amazon docs. I did it when I first learned about it at reInvent 2 or 3 years ago, and it was very easy for me to get it going. So, okay, QR code's going away. All right, light sale. You want me to get this?
You take it.
Okay.
I'll just jump in.
All right. Lightsail is known as the AWS VPS, or Virtual Private Server, I think. It has simple pricing over traditional AWS, and it's marketed towards small shops. You can see here it has one-click deployments for popular stacks, and the pricing is grouped by monthly and everything together instead of for the similar configuration on EC2 instances, you would be paying for the hourly rate for the EC2 instance, and then the storage would be priced separately for EBS, and then data transfer charges would be separate, and it's just a lot more confusing on what your bill is going to be.
So I can speak to this one personally. We run WordPress for one of the businesses that we operate under has a number of properties, and each site has a very simple PHP WordPress page. And we deploy this because we need to have VPC connectivity to talk to some of our other apps, and they're kind of integrated to talk to these data sources. But it costs us a significant amount of money to run the EFS, the ECS service, the database, and everything. This is more like a comparable competitive solution to what you'd see with like DigitalOcean or Heroku or Linode, where you go and you say, I want a server for $5 a month. You're never going to beat this price if it's something simple like a WordPress stack. So if I can't remember where it was, if it was Reddit or somebody else, they were talking about keeping their Amazon costs low and how they use Lightsail to do it because it's cheaper for them to do it on Lightsail as this service, and they get creative with how they store their data in S3 and move it around rather than deploying a fleet of ECS containers and a bunch of services. So this scales. Pardon me?
I think I use EC2 behind the
scenes.
scenes.
This is EC2. There's another version that you see, that's like a competitor to Heroku, also DigitalOcean for Docker containers, where it's App Runner. I haven't used it, but you point at an image. I think you either point it at a repo or you point it at the Docker file, and then it just runs your app for you, and then you can kind of customize the URL and the certificate for it. But it's like, here's the Docker file, go, and it's yeah.
Like a GitHub repo, you can just say, I'm going to run this GitHub repo and
Nice.
I haven't played with it, but let me know how it goes because
I'm like, oh my gosh, that's amazing.
yeah. So
No, that's
App Runner, yeah. Yeah, so don't sleep on. We don't have a slide for it. I just remembered it, but don't sleep on these services if you have really cookie cutter, non-complicated apps that you need to run in your environment, where you're going to not have to pay an arm and a leg for them.
Yeah, and this is also a really great option for students because it removes a lot of the configuration options that can confuse people. And this is just one snippet. So the IPv6 instances are actually cheaper. If you don't need an IPv4 address, you can pay I think $350 for the Linux. And there's also containers, load balancers, databases with Lightsail, but it's less complicated. So like the load balancer option is just a load balancer. It's not like AWS, you have to choose which load balancer you want because there's 4. There's application, network, gateway, and classic. So with Lightsail, you just give me a load balancer. And It's easy. Also, the database is MySQL or Postgres, whereas the other AWS is like 7 offerings if you only include RDS. Oh, this is a QR code of a blog I wrote on Lightsail, if anyone got that.
This will be on the repo. This presentation will be on the repo as well.
Yeah. Okay. Oh, yeah.
So data services, RDS is the one that I have a lot of experience with. We run a lot of relational database workloads, and Amazon doesn't have a sizing tool for relational database services.
Yeah.
Not yet. I'm sure people have been asking for it for a long time. You go to Compute Optimizer and you see the recommended compute sizing. Well, they don't have that for RDS, and for us, it's the most expensive service that we run. So naturally, they get you right in the data. So you have to really do your homework on these. You really got to check your resources that Compute Optimizer would otherwise do for your compute workload. You want to look at your IOPS. Make sure that you're not provisioning more IOPS than your instance can handle. Make sure that you have the right amount of throughput. If your throughput is not high enough, you're going to suck up your EBS credits. So there's a matrix of metrics that involve your compute power and your block storage, and then there's all the myriad of things that go in between. Additionally, if you have an app that has really poorly written queries, it's going to suck up your compute and really tie up your database load. And you can sometimes reduce the work that your RDS instance is doing just by fixing some queries. And when I say by fixing some queries, it's asking the 1 or 2 DBAs that are up to their neck in other work to take a look at this thing you found. But it's usually easier for you to point them in the right direction. So there's a service called Performance Insights, which will tell you how much DB load. That I didn't do a very good job with the red line, but the red line in this instance is a 8 vCPU RDS instance. And this will show you over time what is causing waits on the I/O of the RDS instance. And so if you see spikes that are going above the load average, you want to be looking at those queries and seeing what you can do about them. Sometimes the answer is, it's as good as it's going to get. Sometimes the answer is, well, if it's as good as it's going to get, we're going to have to bump it up. But it'll tell you what database call is being made, what query or transaction is being made, how long it's taking it, and how much load it's causing. So it'll tell you, it's hard to see, but it'll tell you if it's got a table lock, if you have something that's waiting to finish updating, you'll be able to kind of glean some information. This does cost money just to turn this on, but if you're doing a right size and cost audit, you can turn this on briefly, look at your services, turn it off.
If you do turn it on and you are paying for it, make sure you look at it. Otherwise, you're just throwing the money away.
Yeah.
What was that called?
Performance Insights. This is a screen cap of an RDS instance that we just recently changed. Data warehouse pulls in data from a million different places, churns the data over every day. There's stored procedures that run every 5 minutes, and these stored procedures have to complete before the next 5-minute execution. And we started having some problems and creeping up. It was a memory, it's an R5 instance. And you can see where we bumped it 2 generations to a Graviton processor, which substantially lowered the average CPU to a tune of, you see these spikes up here, but it's barely bursting up towards 35%. So Graviton is ARM architecture. You don't have to do anything with an RDS instance under the hood. So it's 20 to 30% cheaper on that alone. And it's more performant to the point where we have a lot of headroom now to build and crunch more data in this instance without having to pay more.
And I think the Graviton instances or chips are custom developed by AWS for AWS, so you can't get them anywhere else.
Yep. There's a difference between 7th generation Graviton and previous. 7th generation Graviton or Amazon processor is Graviton 3. So there's like 3 versions of Graviton. It's the 7th generation of CPUs that they've rolled out. It's the 3rd gravitation of.
Is Graviton 4 not out yet?
Not yet.
Okay. Soon.
Why wouldn't you use Graviton?
Well, I'm going to sound really out of my element here, but when Graviton is at lower CPU utilization, it doesn't perform as well due to the architecture. This is the way I understand it. When it's under high load, it can scale out and perform a little bit better than it would from its x86 counterparts. That's what I've been told. Now, whether that's true and that's what the marketing literature says. But yeah, with EC2, it's more tricky because you may have packages that are written in x86, but they're not compiled, for ARM, so it won't work.
Was the big question.
Yeah, with RDS, it would be a first stop for me. And I've had success with it. Every single thing that we've been able to convert has been an instant win for us. Easy. It's one of the biggest impacts to our costs with the lowest amount of effort. Was changing our data to as much as we could.
I only do it with Bootstrap.
Well, SQL Server is still on, I believe, 5th generation Intel for RDS. It's behind. They don't have maybe 6 now, but there's no Graviton. There's no ARM for that yet.
Okay. Next one we talk about is a newer service from DevOps Guru for RDS. This was announced at reInvent 2022, maybe 23. I don't know. It uses machine learning once you enable it to check your RDS instance and can highlight you to performance bottlenecks and operational issues with some suggestions on how to resolve them. So here's like some of what the recommendations look like. So it said, I can't read that.
High load wait events. The DB load for the CPU and IO wait type was over 21 active sessions. average active sessions. This is 90% of the total DB load.
It tells you some things to look at to confirm their findings, links you to some AWS documentation. And then these are SQL digests, so you can see what queries fall into that category. And if you hover it, you can see like what the SQL query was. This is also not a free service. Once you enable it, you'll be paying for it. And the pricing around it is kind of confusing. It charges you based on the number of data that it scans. So the more data it scans, then the more you'll be charged for it. So if you do turn it on, make sure you look at it. This can be like a great place if you're doing a cost audit or have some trouble instance. I would turn it on just for those instances selectively.
Are there any security issues with having it running? Like, is there any possible chance that you might secure information in, like,
I don't think so.
are the SQL queries parameterized so you don't see like any of the parameters that are passed into them?
I don't
Good question.
think so, but I know you need. I think you need IAM policy access to see this. So
You need pretty elevated permissions to get it in the first place.
yeah.
Performance insight is
I've never seen this until he brought it up the other day, which is good ammunition, especially for operations teams who may not necessarily know what is going on in the database, like me. But when somebody reports a problem, we have to kind of triage and dig in and find out what's going on, right? So it's just another tool for an operations belt or performance bottlenecks and costs, right?
Yeah, and it's a very new service. I haven't dug into it too deeply. There are multiple like layers to it. So this is a DevOps Guru for RDS, but there's also one for serverless, and there's also like one that doesn't have a prefix. It's just DevOps Guru that check different aspects of different things. So I would check it out and see what it can do.
So with RDS savings, stop running Microsoft. Again, it's going to be 3 times as much as MySQL, MariaDB, or Postgres.
My favorite, Postgres.
I think we have an app that we run that uses it, but I've never really used it other than that one app.
You're missing out. All right, we're going to talk about Aurora, which is AWS's proprietary relational database. It has 2 flavors, MySQL and Postgres compatible versions. They claim increased throughput of 5 times over MySQL and 3 times over Postgres. It's proprietary. They built it from the ground up using different design patterns. It replicates data 3 times across different nodes and has like an interesting architecture if you want to read up on it. Should have done a QR code. Oh well. You can have more read replicas with Aurora than any other database service in AWS, I believe, up to 15. It also has options like global database if you want your database to span multiple regions. And it also supports active-active, but not in multiple regions. So active-passive in multiple regions or active-active in a single region. You can do database cloning with Aurora. So you can clone the database and have it available, and the storage layer is shared, so you don't pay for the storage twice. Any deltas to the clone will be written as new storage, but the existing data will be shared between the instances as long as they're unchanged. So if you need to clone databases frequently for like QA, you can clone it, test it, and then delete that database, and you don't have to worry about like paying for storage twice or doing like an update when your staging database falls behind production. That'd be a great feature for that. And then it has different features for different engine types. So like all features aren't supported for both MySQL and Postgres. You kind of have to pick which one you want to use. There's a feature called Backtrack only for MySQL, which lets you update your database in place back to 72 hours. So this is good for like development or non-prod situations where maybe you messed up a schema change and you want to roll back. You can roll back in place. You don't have to do like a snapshot restore, change the DNS names. It just changes it in place, but you will experience downtime. And then there's a Babelfish extension for the Postgres version. This claims that it will provide a MS SQL compatible endpoint that you can send queries to, and it'll translate them into Postgres for you. I know Trent's been exploring this a little bit more.
Today, actually, I went through trying to run a prerequisite check to see if it's compatible with Babelfish on Postgres, and unfortunately, the database has a number of database objects like catalog types that aren't supported. There's not full feature object parity between MS SQL and the Babelfish plugin. So for those who come and keep in touch, like on Discord or whatever. I'll let you know how it goes, because it's one of the things that I'm digging into heavily at the moment. The literature says they make it look like, oh, you can plug your MS SQL workloads into it and off you go. But there's, just like anything else in technology, there's a bunch of caveats.
Yeah. But it still could be a good migration path. If you want to migrate from MS SQL to Postgres, this could help loosen the resistance or make it a little bit easier for you.
I feel like too that it's marketed one way, but really the use case for it is you point your MS SQL apps at this instance, and then you also point your Postgres connections, and you start migrating your queries to Postgres from MySQL using the same endpoint in the same instance where the data resides. I feel like that's a better use case for it rather than being a drop-in for MS SQL. But I am hoping that the fixes are not substantial. So we'll see. But it's still something that's worth looking at. It'll cut your RDS, your MS SQL database costs in half. So for example, if you're running MS SQL in production across multi-AZ, 3 AZs, and you have single AZs in your lower environments, your 2, 3, 4 lower environments, the cost savings is about 50% if it works, right? There's the labor investment, but if you're forced into Microsoft, and a lot of people are, and there's nothing wrong with that, like it's something that you may want to put some elbow grease into, especially if RDS is your number one line item on your bill.
Yeah, and Postgres doesn't have enterprise premium, because MS SQL has standard and enterprise tiers, but enterprise is more expensive. Postgres is just one price. Although Aurora is more expensive than RDS.
Depends.
Really?
Depends on how many nodes you're running, because multi-AZ can be
fair.
With MS SQL also, there's data transfer charges and replication for mirroring.
Okay.
That incurs a lot higher costs. So anyway.
There's also a feature of Aurora, or like another like service, I guess, called Aurora Serverless. There's 2 versions, version 2 and version 1. Version 1 is deprecated. They got some bad feedback and iterated on it, made it better. It still requires a VPC, subnet group, and security groups. That's not very common with serverless services, but it is common with database services. It automatically scales up and down, but it does not scale to 0. So if you use Aurora Serverless V2, I think the minimum cost you'll pay for no traffic is like $40 a month. But that could be still cheaper than what you're paying currently for your non-prod. And maybe if you have really bursty workloads, it might work in prod, but do a lot of testing.
We run our ERP on MySQL, and this is something that is on my radar to check out, because non-prod, would you say it was like the minimum cost is like less than $100 a month?
Like $40 a month.
If you don't use it, yeah.
Yeah. And it scales up very fast because it's technically never off. Okay, next one is Redshift. This is can be very expensive for a lot of people. It's a data warehousing database. So there's some different things that you can look at to optimize your Redshift bill. First is compression. If you're not compressing your data, you should, to reduce your storage costs. It's pretty easy to do. You just type in the button or something. There's a feature called concurrency scaling, which automatically scales up your Redshift cluster by adding additional compute. But this is like throwing extra resources at bad queries if you don't need it, because it'll make your bad queries run really fast, but you'll be paying a lot for it. So only use this if you absolutely need it. Maybe you have like a big blast that you need to prepare for. Maybe executive wants all of his reports done right now. You can turn this on to get them done really fast and then turn it off. So you can look at that. Next one is distribution style. It's a little bit more complicated. So I'll pull up my little graph. There's different distribution styles you can set on your tables in Redshift. Key, all, and even. This spreads the data on the nodes in the underlying system, and it can impact your costs and your performance. So I think even's the default, and it's just used round robin. But if you know for a fact that you're going to be joining 2 tables frequently, you can set them to key, and it'll co-locate them on the same node. So all of your queries don't have to traverse multiple nodes. It'll improve performance, and it'll reduce costs. And then all, if you have very small tables, this will replicate the entire table on every node. That way, you don't have to cross nodes to get that table. It's good for metadata, very small tables. If you set a large table to all, you're going to be paying 2, 3, 4 times the cost of that table. So keep that in mind. There's also auto, which is in here, which is kind of a mix of all and even. If the table's small, it'll be all, and if it grows past a certain point, it'll change it to even for you automatically. So that's what auto does.
So make sure your analytics platform folks know that there's optimizations to how it writes the data.
Yeah.
Not just go dump it there. Think about how it's used. Think about how it's placed there, because you may not get that with your on-premise hosted data warehouse.
All right, next up. Oh, too fast. There's an option to pause. So just like the 24/7, 8 to 5 slide, pause your Redshift cluster if you don't need it. Maybe your analytics team went home for the weekend, long holiday, pause it so you're not paying for it. Also, vacuum your database. And so with Redshift, it doesn't delete the data right away. If you delete the data, it's pretty much marked for deletion. So you have to vacuum the database regularly to remove the records and resort the data. So vacuuming regularly will reduce your storage costs and improve performance. There's a vacuum. Okay. And then workload management. This is a feature that you can enable to set up different queue priorities. So in this example, there we go. They have dashboard, reporting, and default. So the dashboard queue will run at the highest priority, and then reporting will run, and ad hoc is default. So this will ensure that your most important business priorities will get the resources first. And if the ad hoc queries are performing slow, then they have to wait for business priorities, or you can take count of the wait times and then increase your load. You can also change the settings, like concurrency scaling, per queue. So maybe you only want dashboard to use concurrency scaling, everything else doesn't matter. You'll pay more for the concurrency scaling, but maybe it's a high priority that you need that feature. So you can force it to perform faster. Okay, there's also Redshift serverless. It's a common theme. Serverless is becoming very popular lately.
Yeah, especially with near scaling to zero type of thing, right?
Yeah, it seems like every reInvent, there are like 3 new serverless services.
Yeah.
Okay, so this one automatically scales up and down just like Aurora. This one does scale to 0, as far as I can tell, and it's also good for non-prod. There's also a Redshift serverless free trial right now. So if you've never used it before, you can use it for $300 credit for using. I did play around with the free trial. I liked it a lot. It scaled seamlessly for me. I didn't notice any delay at all. Although I was working with gigabytes, not petabytes. I didn't feel like downloading petabytes of useless data to test this with. But it worked good for me. Here's a QR code for the free trial if you're interested. All right. Now
did we talk about data share on those slides?
Oh.
Did I not get in there? If you have an
No, we
analytics team that needs to run another instance of their data, you don't want to pay for your huge data warehouse twice. You create what's called a data share, and you present it to your lower environments, where the lower environments can read from that same data share. You don't have to duplicate it twice and replicate your data manually and import and export. You present it as a resource that it can read.
Yeah. Thought I added that. This might be
I thought you did too.
Slightly out of date.
Yeah.
That's okay.
I'm
Shouldn't
sorry.
have been working until the last
I pulled
minute.
it from the GitHub repo just when I got here.
Okay. Weird. Maybe I committed the wrong one. Okay. So there's a bunch of different services you can use to query data from S3. So S3 is object storage, but you can use standard SQL to query it if you use these services. And here's a little chart that talks about the differences between these 3 services. So first up is Redshift Spectrum. This is a feature of Redshift. You can join data in Redshift with this. So maybe you have hot data and cold data in Redshift. You can move the cold data to S3, reduce your storage costs significantly, and scale down your clusters probably, because it's working with less data, and use Redshift Spectrum to join the data with Redshift. So that's something you want to look at. Although Redshift Spectrum does require a Redshift cluster, so you can't use it if you don't have Redshift. And then Athena is a standalone service that you can use to query data. You don't have to have anything else. It's really great for ad hoc. I used it for feature engineering and a machine learning thing that I was working on, and it worked great. Way better than Jupyter Notebook did for me. And you only pay for the data that's scanned.
Yeah, so there may be a use case where you have something that's being dumped into an S3 bucket, and instead of taking all of that data and loading it into your data warehouse and then running your queries against it, maybe you're making a call to query that data in S3 and then return it and load that. So instead of moving all this data into doing it the way that maybe used to, leveraging these services in combination with each other can drastically reduce the cost if you're doing a lot of those types of queries, or you're doing a lot of unnecessary data loading, for lack of a better term.
And Athena pairs greatly with Glue. You can use Glue to scan your S3 bucket and create a schema for you, and then query it that way. You can also use Athena to query commonly developed AWS logs. Like there's a built-in template for querying CloudTrail logs with Athena. So maybe you want to look at your CloudTrail logs a little bit easier with SQL instead of their interface or other custom tooling that you want to look at. So I really love Athena. There's another one called S3 Select and Glacier Select. if you're querying from Glacier. This is better if you're looking at like a specific file and you want to get access to it. You can use S3. You can't do any joins in this. It's I think it's just a single file. I haven't played around with it too much. I prefer Athena, and the costs are about the same. For the feature engineering I did with Athena, I paid 2 cents for all that work I did. And I probably ran, I don't know, a couple hundred queries.
So network savings.
This is all you.
Networking is a black box to a lot of people. Where I started my IT career was internet service provider networking and city networking. Anyhow, networking is one of those disciplines that is usually lagging behind operational transitions to a more development-focused process. And there's a lot of reasons for that. But what I have seen commonly is that network teams will try to continue to do things or partially in the way that they're used to, working with vendors that they're used to, buying Cisco, buying Fortinet, buying Palo Alto. The thing is that when you transition to the cloud, you can still use some of these services, but you have to be very thoughtful about it because it's very, very, very cumbersome to run it in the wrong way. So for things like routing in between regions, I've seen customers backhaul all their stuff to a co-location on-prem instead of using Transit Gateway, right? Sometimes teams need to justify their existence. But usually, the bottom line is what justifies the existence at the end of the day. So using Amazon native services, don't use drop-in Cisco. Focus on around meeting your compliance needs, but also trying to leverage these cloud native services. Can't stress it enough. We pay $20,000 a year for global networking. You can't buy a 48-port PoE switch for $20,000. And that's just that's global networking. If you think about the time that it would take to set up just a couple edge routers that peered across, it would take you months and hundreds of thousands of dollars in circuit fees and operational staff and whatever. So anyhow, Amazon services is the #1 cost-saving thing. Build your architectures around it as long as you can to stay within compliance. Yeah. The next is don't deploy more availability zones that you need. We use CloudFormation, and we have a very centric approach to all of our infrastructure as code. It doesn't live in all the code repos. It's all piled into one big per account repo, so we have a number of accounts. And the foundation of setting up these services for these accounts is declaring how many availability zones you have. Well, at first glance, you're like, well, this region, US East 2, has 5 now, or whatever it is. You don't need to deploy 5. If you're only going to be deploying redundant workloads and you only need 2 data centers a certain amount of distance apart, deploy 2 availability zones, at the most 3. Well, why does this matter? Well, when you build your tooling around selecting from a list of availability zones, every single time you deploy a service, you start placing multiple endpoints into all these availability zones. Things like NAT gateways that have a $25 a month minimum charge. Things like Transit Gateway endpoints that, they add up over hundreds of VPCs. You have hundreds of endpoints, thousands of dollars a month just sitting there. So make sure that when you lay the foundation for your infrastructure as code, that you're not foot-gunning yourself and deploying something that you might accidentally be deploying twice as much as you need. Try to use IPsec as much as possible with your hybrid deployments. IPsec comes with a redundant tunnel, routes over the internet, and is usually 20 milliseconds faster than dedicated circuits that go through co-locations and data centers. And you'll pay way less for them, it depends on your data usage, but Direct Connect is a 1 circuit to a region, and it has a lot of restrictions, and it costs a lot, and you get locked into 3-year contracts, and it's just not great. So if you can use IPsec, don't be scared of routing your traffic over the internet. It actually works pretty darn good. You usually get sub 100 milliseconds from your on-premise locations to the nearest region. And the AWS service that uses this is site-to-site VPN. Yep. And then lastly, be aware of where you're placing your components. Don't put some web server that needs to communicate with some other service a region away or in a different VPC where you may be incurring transfer charges. Don't place your load balancers on the internet when they can reach it in the same VPC at no transfer cost. So transfer costs can be a significant cost for a lot of public-facing SaaS services and whatnot. So just be aware of data transfer fees across regions and to the internet and back. Especially if you're sending large amounts of data, like a video upload site or Netflix streaming site, you want to really look at that because that's going to add up fast. So I talked about availability zones, network endpoints. So we talked about that. I'll just touch on it again. With Transit Gateway, you could adopt a VPC approach that has maybe 2 subnets that has endpoints in it. There's a managed VPN service, SSL VPN. You only need 2 of those. You don't need to deploy that in all 4. So always be thinking about your endpoints because your endpoints have a monthly charge associated with them plus transfer fee. And then if you're using things like Dynamo or S3, make sure that you're deploying private endpoints into your private subnets so they don't have to go out to the internet to hit s3.amazon.aws.com. If you have a local endpoint, local DNS will resolve that traffic to a local endpoint and there will be no data charges associated with it.
Also travels over the AWS backbone, so there's less jitter.
The global networking is with Amazon I'm really impressed with. How fast it is and reliable. So if you have a bunch of unused NAT gateways sitting around, delete them. If you have a bunch of unallocated public IPs, there's now a public IP and an EIP charge associated. So like having a public interface is like $20-something a month just for a public IP. It's like 15, I think, and then plus the cost. So those add up quick. Make sure you delete the ones you don't need. If you're running a small environment or you're setting up multiple environments and you just need to have a few VPCs talking, VPC peering between 2 VPCs within the same region is free. So VPC to VPC traffic is completely free. Now this is great if you're running 4, 5, 6, maybe 6 VPCs in an environment. But if you think about if you have a requirement for full mesh, every single time you add 1 VPC, you need to create 7 different connections. And then when you have 8, you need to add 8 different connections so it does not scale. But it's really cost effective when you're exploring and testing things out. At that point, you want to move to Transit Gateway or Cloud WAN at that point.
Yeah.
So backups, logging, and S3. These are things that can run away on you pretty quick. When you create a Lambda service and you give it the default role, it is given permission to create a CloudWatch log group on your behalf and start writing logs there with no retention policy, of course. So you have your logging. If you roll out a backup service, make sure you have a menu that's tiered, and if you are backing things up that you shouldn't, it's going to be one right below RDS. You can ask me how I know. So with backups, it's really important that you monitor your backup metrics and you look at that cost regularly. You set up those cost anomaly monitors to say, we're passing a certain threshold with backups, we need to take a look at this. That data warehouse I talked about, churning lots of data. When a snapshot is taken, it's taken at the EBS level. And every delta is the amount of space that you're charged. So if it's a 2 terabyte snapshot today, and all of that data is new tomorrow, it's a 2 terabyte snapshot tomorrow. And the longer you hold that data, the more you're paying for that same amount of data on a daily basis. An analytics warehouse may be able to be rebuilt and reconstructed from all these different data sources and backfilled, it may not. So these are things that need to be evaluated on a case-by-case basis. But those are kind of edge cases. There's the general rule of thumb that I follow is your application servers should be cattle, or you should be able to redeploy them within a reasonable amount of time from scratch. So don't back up anything that doesn't hold the data, right? Back up your data, but not the cattle.
Yeah. If you're using infrastructure as code, it should be easy. With CloudFormation, CDK, Terraform, you can use those to deploy your application servers very easily.
So there's a certain maturity that comes with this too. You know, you can have your infrastructure as code, but you may not have your AMI pre-baked with your configuration management. So if you do need to redeploy, is it acceptable to run a vanilla server, join it to your domain, run your configuration management to it, then deploy your code, then get your app up? Well, yes and no. You have to consult with the business owners on that, or your application owners. But there's layers of maturity that come with it, and you want to get to the point where you can just click one button and it rotates out a brand new instance with your app fresh to go. So logging, don't log everything unless you need to. If you have a compliance reason to do so, then obviously you have to do it. But you don't have to back everything up, and you have to analyze that and go through your apps with looking at what the high line items are, or the high cost line items. So the other thing too is that if you're using Amazon Control Tower, you have an account structure that is required. One of those is a log account. And when you set up Control Tower, it will ask you, how long do you need to keep all of your auditing logs for? Well, a lot of people ship their logs to an observability platform. You don't need to keep those for 7 years, or maybe you do, but you're keeping them somewhere else. Don't pay for it twice. Don't pay for it in another vendor. Don't pay for it in your own. Archive required logs with S3. Anything that you don't over a year old, put it in the cheapest tier and deal with how long it takes you to get your data out.
And Glacier Deep Archive will be way, way cheaper than S3, but you'll pay for retention, or you'll pay when you retrieve it.
Yeah.
Retrieval.
Cheap to store, expensive to retrieve, right?
Yeah. So put it there and forget about it.
Yeah, and hopefully you don't ever have to touch it. And then CloudWatch lifecycle policies. There's tools out there that exist. There's an open source tool that we use to find ones that aren't tagged and automatically apply a policy to them, so it rotates them out.
There's this this blog post I linked to here in the QR code that did a case study on CloudWatch logs versus other providers like Datadog and stuff like that. The CloudWatch ingest is one of the highest in the industry, 50 cents per gigabyte. So if you're ingesting a lot of data, it's going to be very expensive. You can look at other options like S3 or Datadog to reduce those costs. CloudWatch has a lot of features like real-time functionality that you may not need, that you're going to be paying for just by using CloudWatch. And like Trent mentioned earlier, a lot of services have it pre-enabled and set up. So if you deploy a Lambda function, it's going to start spitting CloudWatch logs immediately. So if that's not what you want, then you'll have to re-architect to do it. And it's a little bit more work, but it may be the right thing depending on your use case.
Be careful with Datadog. They're not inexpensive.
Yeah. The Datadog ingest is cheap.
Yeah,
But they'll get you somewhere else.
Oh yeah, we're Datadog customers.
Okay, I can get this one.
Go for it.
So make sure you're monitoring, alerting, and notifying on your S3 buckets. Maybe you have like a steady grow and then it just spikes up. You want to be alerted of that. So if someone starts writing like random terabytes to your bucket, you want to be alerted to that. There's different storage classes for S3. Be careful with intelligent tiering. I'm going to go over all of those right here. Okay, so these are all the current. No, there's one missing. This is most of the storage classes. S3 standard is the default. It's the fastest. Very redundant. You'll get your data in milliseconds. You're going to pay the most for it. Intelligent tiering uses machine learning to automatically move your data between standard and S3 infrequent access. That's what the IA stands for. However, you will be paying a monitoring fee. So they'll charge you for monitoring those objects. It may work if you're not sure on your access patterns, use intelligent tiering. But if you are sure, like this is never going to be accessed or infrequently or very frequently, you'll save money by putting it in the right storage class from the beginning. I would never recommend using one zone. It's not that much cheaper than standard infrequent access, but if the zone goes down, you lose it. You might be able to consider it if you're able to regenerate the data you put in it, but if you're not, then I wouldn't. And then Glacier and Glacier Deep Archive, we already talked about a little bit. Archival costs, very low costs, but you're going to pay for retrieval. Deep Archive, you're going to be looking at hours to get the data back. All right. Oh, too fast. Okay. So you can set up lifecycle policies, just like with CloudWatch, to move your data. So maybe it starts in standard, then it goes to frequent access after 30 days, then it goes to Glacier after 90 days. So make sure you do that. Also keep in mind with like the lower storage classes like Glacier and infrequent access, there's a minimum storage duration. So like if you put an object in Glacier Deep Archive for 1 day and delete it, you're going to be paying 180 days for that object, whether it's there or not, because that's the minimum. Watch out for Glacier data retention fees and consider transfer fees when transferring objects out to the internet. Anything else you want to cover there?
Nope.
Okay.
There's a myriad of Amazon tools that we've covered and shown some slides of. We're just going to touch on these because we're running low on time. Compute Optimizer is that right-sizing tool.
Here's a picture.
Yep. AWS Config is a detection service that scans your account with policies and will notify you. But be careful with Amazon Config. There's a couple different recording modes, and the larger your account is, the more you're going to pay because it's per resource scanned. We've used it in the past. We've since turned it off because it's too cost prohibitive and replaced it with some other third-party tools.
And Config is a proactive tool. It's not a it's reactive.
Yeah, it's a detective not preventative.
It will not stop someone from breaking your compliance rules. It'll just mark that resource as not compliant.
Yep, and it'll notify you.
And then you can trigger some like auto remediation, but it's all manual on your own on your end.
Cost Explorer is the query, nice, pretty line graphs that we can filter by tags and usage and whatnot.
Very handy.
Event Bridge is one of the services that's used to trigger an event, such as resizing your EC2 instances or your compute. A few different services in that suite, I should say, Event Bridge.
Yeah. And you can also use Event Bridge to create a custom event bus if you want to have like a hub to send all your events to, and other applications can read from it. If you're familiar with that architecture.
Service control policies. These are policies if you're running control tower organizations that you can apply to all of your organizations. Don't allow expensive instances. Don't allow over a certain size. Don't allow anyone to deploy into a specific region. Don't use these certain, don't let this person do this. So just be restrictive on things that somebody could really hit you with.
These are free, and they are they're evaluated with IAM for like any permission request to see if it will be allowed or denied. Oh, forgot the picture.
Trusted advisor, machine learning under the hood to make a bunch of recommendations. Some are cost, some are security related.
Yeah, so you can see security checks, fault tolerance. They'll give you an explanation of why they think you should change it, what resources are impacted, and it also has a cost section, so it can give you some cost savings. This is looking at stuff like Compute Optimizer and stuff like that. So if you follow those recommendations, maybe you can save that much money.
Yeah, it ties into the other services. It's more of a notification, well, kind of part of their monitoring. I love Cloud Custodian. This is an open source project that I don't remember who owns or sponsors it, but it's a YAML policy that you run in a Docker container, and depending on how you configure your policy depends on how these policies are enforced. You can have a Docker container run it at execution, or you can have it create a Lambda on your behalf that scans your account and does it for you in the cloud without having to run the container every time. We use this for when somebody launches a DC2 instance and it doesn't have their name on it, it auto tags and it looks at the IAM user that launches it. We do this to look for resources that are deployed without tags and then auto tags them or notify people to make sure that it's tagged or to remediate it. We use it to notify us when backups are left around over 60 days old and auto cleans them up. We use it to tag all of our set policies for our S3 buckets and our cloud logs. A great tool. Very, very cost effective because it's just under the hood. It's running Lambda and Event Bridge.
Yeah, Lambda is very affordable. You can see here in the filter, if the EBS is not encrypted, then terminate it.
Oh, and then the other thing that we do with it as well is we turn off our EC2 on a schedule with this at night and weekends and whatnot, and scale our ECS to 0.
Do anything with like CDK or something like that to stop it?
No, because they write all the code for, like if you go to their documentation, there's a number of like filters that you can run and they control all of that. There isn't anything for them to execute something of your own to say like, you just declare, like you have to run within the rigid confines of what they support and what they don't support. So other things is if you're running, we run our own infrastructure as code tool that's written in Python, and we have CFN lint that's run on CloudFormation, and we have a number of linting policies that prevent any pull requests from going in. So this is especially useful for large teams that may or may not know that they can or can't deploy something. But really leverage, that's a prevention technique. Config was a detective technique. We use linting to stop it in its tracks before it even gets deployed.
Yeah, Verizon used this too when I was there. If I tried to write like a CloudFormation template to deploy an S3 bucket, it would say, nope, can't do that. And then it would point me to the documentation to deploy the S3 bucket the right way.
Yep, so we talked about CI checks.
Yep.
All right,
Purchasing options.
go for it. Is that the last section we got?
Yeah, I think so.
Cool.
Okay, spot instances, promise we'd come back to this. This is spare capacity. So AWS has all these racks. Sometimes they're not 100% utilized. So that's the spot instances. They want people to use them. They don't want them to sit idle. They'll give you them at a great discount over on demand. And you can look at this instance advisor to see how frequently different instance types are being interrupted. So with spot instances, they can be terminated. So if a paying customer wants to pay full price for it, then they're going to kick you off and give it to them instead, right? Supply and demand. So maybe you right size your instance to medium, and you can run the same workload on 2 smalls instead, and it won't be as interrupted as often. So maybe look at that. Good for non-prod. I have seen people use spot instances in production, especially with EKS. It's very popular because Kubernetes is really good at relaunching pods and rebalancing across different nodes. So it can handle it very easily. It's supported by multiple services, EC2, ECS, EKS, and a lot of other services that use instances will also use spot, like batch. Reserved instances, 2 main types, standard and convertible. You're going to get a bigger discount with standard than you are convertible, but convertible is more flexible. So you can exchange convertible reserved instances if you want, but they require a commitment. So I'm going to get this instance for a year, for 3 years, and then you can pay all upfront, partial, or no upfront. But the discount is higher if you pay all upfront.
We do 1 year reserved on our RDS Aurora because it's super expensive.
Yeah.
And we do it annually because it may change in a year.
Yeah, exactly. I wouldn't recommend the 3 year instances for that. AWS is changing so rapidly that you may not know what's going to be available in 3 years. You don't want to lock yourself into a commitment that long, unless maybe it's for like a legacy workload that's never going to change. And with reserved instance standard, you can sell them on the marketplace. AWS will take like 80% cut off of that, and it has to have more than 1 month remaining. All right, there's some different savings plans you can look at. Compute savings plan works for these services, EC2, Fargate, and Lambda. Fargate's used by ECS and EKS. And then there's an EC2 savings plan. This will offer greater savings than the previous one, but it's less flexible. That's a common theme. The better the savings, the less flexible it is. And then SageMaker, this is a AWS machine learning service. If you are using that, you can use this. And then here's a pricing calculator snippet that shows different savings plans and options for a G6 extra large instance. So if we do on demand, we're looking at $587 a month. And the G6 is that high performance GPU powered instance. Spot instances, average discount is 88%, so it'd be $70 a month. Drastic savings there. And then compute savings plan, EC2 instance plans for 1 year, all up front, looking at $5,000 and $4,000. So like before, this one's cheaper but less flexible. It just depends on your use case. That's a G6 jet.
So the last section is about planning and the soft side of all this. You have to plan realistically. Cost auditing takes time. It doesn't take long to run up your bill, but it takes a long time to burn it down. Because it takes time to look at everything. You know, looming deadlines and requirements to get things out the door a certain amount of time. You want to plan for it to take about a quarter, depending on the size of your environment and how often you're doing it. I've been in the throes of doing one. We do one annually at my org. It's about 3 months, mainly 2 people doing most of the work that, you know, we're coming to close. But you have to plan for a team commitment. It's going to tie up one or two of your engineers for almost a whole quarter when they're reaching out and figuring and prodding and learning about your environment. Migration efforts may continue after the audit. So you may have identified all the cost savings, but it may take your development team X amount of months to convert this or test that, or maybe plan it for the next quarter. So you may complete the audit, but the work will continue after. And if you are performing audits on a regular basis and using some of the tools at your disposal, they take less time. So it's just like your house. You know, you keep your house clean. It doesn't take that long to clean it if you're cleaning it every week. Or in this case, every year.
Right.
Yeah. And then it's really important to establish written policy and procedure. Starting with the tags. You establish a procedure and a policy for how things need to be dictated, an architecture, and then a policy, how to enact that policy or that architecture. But it all starts and sticks with accountability. So accountability means certain people are responsible for spend in your organization. You attach a dollar amount to somebody's role or somebody's name. And accountability breeds responsibility, which is a quote that I put up here. So if nobody's accountable, then no one's going to be able to respond. So in our org, we've implemented something called architectural decision records. There's a variation of this that Google uses called ADLs. And what it is, we use Jira, and it's just a simple project that has a ticket that shows who is the one who made a decision, who peer reviewed it, and how much money is attached to it. And that holds somebody accountable for when they say, I need this new RDS workload and it's going to cost $4,000. Somebody else QAs it and says, yep, this is what we want to put in. It's going to cost this amount of money. So we tie somebody to the dollar amount, who approved it, and then you can tie that ticket, depending on your service, to your work ticket. So you have an accounting of who did the work. You have an accounting of who approved the work. And then you use an accountability framework on top of it. We use a variation of what's RACI here. RACI stands for responsible, accountable, consulted, and informed. And what this is this is a database, for lack of a better term, that calls out for every single application in our entire organization, who is responsible for it, who is accountable for it. When something breaks, who is consulted, or when there's cost. And you tie the people that are in these LACI matrices to the decision making. And then you have an auditing policy, which I mentioned before. You tell your team how often, how to do it, and then you document it. And then this is an example of, I didn't put the dollar amounts on there for obvious reasons, but through migrating, shutting things off, downsizing, turning off, cleaning up, auto tagging, so on and so forth. And we're not even done. It's 22% savings. You know, if you're spending a couple $1 million a year, that's a lot of money.
All right.
That's our presentation. We do have a Discord that you can join in. We haven't been super active there lately, but I do plan on collaborating with the community and people there. You can connect with us, ask any questions. We do this on a volunteer basis, so sometimes there's more activity than others. There's some app channels in there for you students who maybe are interested in writing some code and getting some experience there. I do plan on writing some apps with Amazon services, I wrote a PR bot with Bedrock, their AI service that analyzes our PRs and spits it in there, and so that's fed in there, and there was discussion that was being had there, and so anyway, come and hang out with us.
And I follow a bunch of different newsletters. I think I follow 4 or 5 different newsletters just to try and stay up to date with all the changes. And if I see something cool, I'll share it in the Discord. I'll be like, hey, did you know this? I shared the EC2 shop there. I share a bunch of stuff there. I was just recently studying for all my exam recertifications, and I came across some new services I wasn't familiar with, like DevOps Guru. I shared that there. So it might be a way to just stay up to date with what's happening in the ecosystem.
Justin's Wheeler Universe on all socials. I'm T Nielsen too, and then you can find the GitHub repo where this PowerPoint presentation is stored. It's west-michigan-aws-users-group. It's the same name. I'm sure if you search for it by GitHub, you'll be able to find it.
And we'll link it in the Discord too.
Got any questions?
I think we can do the raffle.
Oh yeah, we need to do the raffle. Thank you.